Hi students, and welcome to this first video in your second lecture on Lewis structures. In this video, we're going to go over how odd electron systems work. And you might start off confused about the name, but I promise that we'll get into why it's named that way in a little bit. So to understand this concept, we are going to consider the example of NO2. And we're going to use the same steps on the left-hand side of the screen that we did for all of our other Lewis structures. So first, we're going to identify the central atom. The central atom is the most electropositive, which is nitrogen in this case. So nitrogen is going to be our central atom. And then next, we need to calculate steric number. So I have the steric number formula above, and the valence electrons from the central atom, nitrogen, is 5. Oxygen contributes no electrons, so we're going to have a 0. There's no charge on this molecule, so it's going to be 0. You're going to divide this by 2, and you're going to get 2.5. Now, as soon as you see a fraction for your steric number, you should immediately think that there's a problem going on. So, for example, if I pull up the steric number chart, you can see that all of the steric numbers are whole numbers. So how can you tell the molecular shape if you have a fraction as your steric number? And the way to do this is what you're going to do is you're going to round up to a steric number of 3. And we'll talk about what that means in a little bit. But for now, I want to go back to why our steric number was a fraction. So our steric number was a fraction because our numerator was odd. And what is our numerator in the steric number formula? Our numerator is the number of electrons available. So you have an odd number of electrons in your numerator. And that's why you end up with a fraction as your steric number. That's why this is called an odd electron system. So what are you doing by rounding up? What you're doing is you are adding an electron to the system. So you've changed that numerator from a 5 to a 6. So you're getting 6 over 2, which equals 3. And you're doing this by adding an electron. So now you're no longer considering the molecule NO2. Instead, you're considering the molecule NO2 minus. So now what we're going to do is we are going to continue with the rest of the steps for NO2 minus. And then at the end, we're going to remove the electron that we added. And that's how we're going to get the correct Lewis structure. So let's continue from here. We have NO2 minus with a steric number of 3. And we have only 2 peripheral atoms. So that means that with an SN of 3, we're going to have the parent minus 1 structure, which is going to be bent. So now I'm going to draw my atoms in that framework and connect them with a single bond. Now we need to fulfill the steric number. So currently I only have 2 electron groups around nitrogen, the bonds to the oxygens. However, I need to have a third. What's going to be that third? We're going to add a lone pair of electrons to the nitrogen. We're not going to add 2 lone pairs because then that would make a steric number of 4. So we're just going to add 1 lone pair to get a steric number of 3. Now we're going to fulfill the next step, step 4, where we're going to fulfill the octet rule for the central atom. So we can't add any more electrons to get a total of 8 electrons around nitrogen. However, currently we only have 6 electrons around nitrogen, 2 from the lone electron pair and 4 from the bonds. So we need to figure out another way to add 2 electrons and fulfill the octet rule. And that's going to happen by creating a double bond to the oxygen. Now we're going to move on to step 5. We're going to fulfill the octet rule for the peripheral atoms just by adding in lone electron pairs. And now we're going to minimize formal charges for this structure. So let's calculate the formal charge for all of these atoms. So for nitrogen, it's going to be, I have the formal charge formula at the top. You start off with 5 valence electrons, you have 2 lone electrons, and 3 bonds. So you're going to have a formal charge of 0. For the oxygen with the double bond, you start with 6. You have 4 lone electrons and 2 bonds, so you're going to get a formal charge of 0. And then for the oxygen with only 1 bond, you start off with 6. You have 6 lone electrons and 1 bond. So this is going to have a -1 formal charge. Now, before we say that this is the complete Lewis structure, remember what we did. All of this was under the assumption that we're adding an electron. So now we need to remove that electron. But where do you remove that electron from? So you're going to remove the electron from the most electropositive atom, the one that's most willing to give up the electron. And in this case, that's the central atom, the nitrogen. So I'm going to remove an electron from nitrogen. I'm going to redraw my Lewis structure. And now the only thing that I need to add to this is I haven't changed any of the formal charges for my oxygens. They retain the same number of lone electrons and bonds. But by removing an electron from nitrogen, I did change the formal charge of nitrogen. So I'm going to have to recalculate that. So now I have only 1 lone electron and 3 bonds. So I have a formal charge of +1. Now notice that previously in this structure, we had only a formal charge of -1, and that makes sense because the overall charge on our structure was -1. However, here, the +1 and the -1 formal charges cancel out, which makes sense because NO2 is a neutral molecule. It's not an ion. Now, just as a last note here, currently nitrogen does not fulfill the octet rule, and that is okay, because when you have an odd electron system, you're not going to be able to fulfill the octet rule for everyone because you don't have enough electrons. So keep that in mind when you run into another odd electron system problem.